In this video, let's review how to graph a line from either the standard or slope-intercepts forms of the line. The equation we're going to consider in this example is 6x minus 4y equals 24. Notice that as written, this equation is in standard form. Recall that standard form in its most general sense is a times x plus b times y equals c, where the numbers a, b, and c are all placeholders for constants, and x and y are our variables. If I have an equation in standard form, while I can plot any 2 points and draw the line in between, the best choices, especially to help us determine the scale I need to understand the graph, are the x and y intercept points. The x-intercept point and y-intercept point come when we assign the other variable, y or x, equal to 0. So I've set up my chart here that we can use to help determine solutions to an equation. To find the x-intercept point, I'm going to replace y with 0, and I'm going to write my equation 6x minus 4 times 0 equals 24. And I go along and solve this equation. 6x minus 4 times 0, that's 6 minus 0, or just 6x. So I'm solving the equation 6x equals 24. Have a number times x on the left-hand side of the equation and a constant on the right. By multiplying both sides by the reciprocal or dividing by the coefficient, I can obtain the value for x. So in this example, I get x equals 4, and therefore I write 4 in for x. In that first row, I have established that the point 4, 0 is the x-intercept and part of my graph. Now we switch this process, and we're going to set in a value for x of 0. And once again, we're going to solve the linear equation after we substitute. So we have 6 times 0 minus 4y equals 24. Now it's the 6 times 0 term. That is 0 and disappears. So we're left with negative 4y equals 24. When we divide both sides of this equation by the coefficient negative 4 on y, what we're left with is y equals negative 6, because 24 divided by negative 4 is negative 6. This gives us a second point, 0, negative 6, and this is the y-intercept. Now that I have 2 points on the line, I can go ahead and graph the line by plotting these 2 intercepts and drawing a line through the points. I notice that I need my y's to go all the way to negative 6. My x's need to go to positive 4. So I want to make sure that when I plot this graph, I have room for all of that. So 1, 2, 3, 4, 5, 6 down, negative 6, and 1, 2, 3, 4 needs to be part of my graph. There we are. Looking at the first point, I had the x-intercept. That's a point on the x-axis, and its coordinates were 4, 0. So I'm plotting that 4, 0 point first. That's going to be right there. Next, I'm going to need to plot the point for the y-intercept. That's 0, negative 6, which would be here. Finally, I'm going to draw the line between these 2 points. And not just between them, I don't just want a line segment, but I want a line that extends for all values of x. So I want to make sure to extend it out, and to really indicate it goes on forever, let's remember to put arrows on our line.